So let's start off by this. Let's start by thinking, okay, what are some real-life examples that might involve a quadratic?
Don't know. Nothing to do with the graph. Math, accounting thing.
What does a quadratic look like? Let's start with that.
A line. Quadratic.
Like a straight line?
No. Like you.
It's like either an upside down view or a right side up view. It's going to be that U shape. Alright, so let's think about this. When do you see that U shape anywhere in life?
Math. My house. Oh.
Where at your house? What are you doing right now? Throwing a ping pong ball back and forth through the air. Is that making a quadratic shape?
Yes.
Alright, so throwing things. Oh.
Ping pong ball.
So any sort of projectile motion, is quadratic. Throwing things. Yeah, I do this then.
You need to get under 10 bucks.
I do.
What?
I can't read that.
Okay, so that's, you know what it says, throwing things. What's another example? What? Archways in a house? Okay.
That's what I was talking about. I said my house.
Archways or just architecture in general?
Ooh, I have something here. Dollars.
Done.
Like shooting a bow in the air.
Shooting a bow? Okay. We'll put that under projectile motion as well, or we'll say projectile. Still projectile. Good.
Weatherman.
What?
A weatherman.
A weatherman?
Like how on the graphs.
Alright, so we'll say storm fronts, or like storm, if I can spell storm right, strong. So weather patterns can sometimes have a quadratic shape. What? A rainbow. Okay. A U-turn.
Weather wire.
So let's say rainbow, U-turns, and that U shape. So when we have a U shape, we have sort of two situations. It can either be going down, like that, or it can be going, up or down, depending on sort of like the situation we have. So if it's facing up, we have that minimum value. If it's facing down, we have a maximum value. So anytime you're looking for like anytime you're trying to optimize a situation, you're trying to look for what's the most optimal amount to like cost versus production, businesses use quadratics. So let's say, okay, it costs this much for this much amount to create this item. So what would be that optimal amount to make to decrease the cost of most amount? And so quadratics can also be used in businesses. It can be used in stocks. What are some of my examples? Sports, constructions, physics, anything you do. Anytime you have speed and something's like speeding up or accelerating, the speed is modeled by a quadratic. So anything you might use in physical science like speed. Boys, what did I say about those ping pong balls? Why don't you put away, please? So these are just a few examples. So on your state test, most likely they're not just going to give you a quadratic and ask you to solve it. I mean, it's possible. They might give you that. But the majority of the time, they're going to give you a situation. And they'll say, this situation is modeled by this quadratic, or something about this situation is modeled by a quadratic. And then using that quadratic, you're going to have to look for some piece. And then that's what we're going to have to look for. So there's typically about 4 types of pieces that show up with your quadratics. And typically 4 things we're looking for. So there's the initial value. There's a maximum or minimum value. When the function equals 0, boys. Stop.
Jarvis.
And then the last thing is time intervals, and we'll talk about the time intervals. So when they're talking about the initial value, they're talking about what is the starting point, how much, or what is the height of something once before it gets thrown? What is the base value of something before it starts increasing or decreasing? So this is the starting value, or what was the speed of a car before it starts accelerating? So for a starting value, anytime you're looking for that, all we're actually looking for is the y-intercept. It's always just going to be that y-intercept. Which is pretty nice, because if we have ax squared plus bx plus c, that y-intercept is always going to be c. So for starting, anytime they're asking you for a starting value or initial height or initial amount or something like that, typically all you have to do is look for that c of the quadratic, and that's going to be your value. Once again, for a quadratic to actually be a quadratic, it doesn't have to have all of these information. It just means that x squared. But, so we'll see some examples where they might not have a c, they might not have a b, they might not have an a. That's okay. As long as it has that x squared in it, that's what we're looking for. So we'll see different interpretations, because not every situation is modeled by a nice perfect quadratic. Sometimes you're going to get some ugly quadratics. That's okay. So that's one thing we're looking for. Another thing they might ask you for is when was the, if you throw a ball, when is that ball going to hit the maximum amount, or when is a stock going to reach the lowest value on its stock? Or a power line has that curve, so when is the power line dipping the lowest to the ground? So those are looking for those maximum or minimum amounts. So anytime they're looking for a maximum or minimum, they should say they're looking for like either the highest, the maximum, tallest, something. They'll say one of those words that should tip you off that you're looking for a maximum. When we're doing this, we have something called the opposite of b over 2a. If you take the b of your quadratic, you take your a of your quadratic, plug it into that little formula right there, the opposite of b over 2a, that will give you the x-coordinate of that point. Once again, that maximum or minimum point, we call that the vertex. So the opposite of b over 2a will give you the x-coordinate of your vertex. In order to get the y value, what was the actual height at that point, or what was the actual, or this gives you sort of like when the vertex occurs, plugging in the actual value back into the function, so finding what was f of x at that point. If you plug that opposite of b of 2a back into there, that'll actually tell you what is the value. What was the highest value? What was the minimum value? So opposite of b over 2a is when it occurs. Plugging it back in will give you the actual amount. Anytime we're looking for a maximum or minimum, that's what we're looking for. Now with projectile motions, typically we end up taking a ball and you're going to throw it. Oftentimes we want to know, how far did I throw it? When does it hit the ground? When does it stop? Anytime a function is equal to 0, if you're looking for the height, when that height is equal to 0, that's when it hits the ground. That's when it stops moving. That's when it sort of, I don't know, equals out. So, it's ground, or it stops moving. So these are all when your quadratic is equal to 0. So solving when a quadratic was equal to 0, we talked about that past 2 weeks, solving quadratics. We talked about how to do it through quadratic formula, was what we did last week. And the week before that, we talked about even how to solve them using factoring. You know what a factor is, and set each of those factors equal to 0. So the thing is, with the quadratic, we are going to get 2 x-intercepts. Almost always when we're solving, assuming it hit the ground, you're going to get those 2 x-intercepts. Oftentimes with these questions, you're going to have to figure out, okay, which of those x-intercepts is actually the right answer? Is it this one, or is that one? If I threw my football and I got -5 and 30 as my 2 answers, which answer is probably going to be right? -5 feet or 30 feet? 30 feet. I want to go in the positive. I'm going to go in that positive direction. So sometimes we might have to use a little reasoning to determine, okay, which of these answers is actually my right one. But for that, we can use quadratic formula or factoring will be our two methods of solving those. And then the last thing is time intervals, which we haven't really looked at. Time intervals are, when is this, if I throw a ball in the air, between what time is that ball increasing? Or what time is that ball decreasing through the air? What interval, if I have a stock, what days is my stock increasing versus what day is my stock decreasing? So when we get these time intervals, your quadratic is going to have some sort of motion. And depending on, you're typically almost always going to be looking for when is it increasing versus decreasing. Well, we can see my quadratic is increasing. If I have a football flying through the air, it's increasing from when I throw it all the way up to hit that highest point. And then from there, it's going to start decreasing. Think of it like a roller coaster. So we would have to figure out, okay, what is the time frame from here to here? Well, that's going to be from 0 to when I hit my maximum value, which we said the point at which we hit our maximum value, once again, is going to be that opposite of b over 2a. So we're going to look for an interval from 0 to opposite of b over 2a. Or if we're looking for a decreasing, we're trying to figure out when our quadratic is decreasing, what we have to do, well, it's from opposite of b over 2a to whenever my quadratic hits the ground. So sometimes we're going to have to solve a little bit extra. So there's a lot of things that these questions might ask. There's a lot of things that these questions might be looking for. And so one of the things that we need to do is we have to read the question and be able to determine, okay, what is it looking for? What is it asking? What am I trying to find? What am I trying to solve for? So we'll have to do a little reasoning, and then we'll have to figure out, okay, which of these do I need to do? And then once you figure it out, okay, I'm solving for a maximum minimum, so I need to go through A, B, C. I'm solving for time interval, so I need to do these steps. And so one of the biggest things is just being able to determine what you're looking for and then remembering how to do it. And because there are 4 different options, sometimes it can be a little confusing to remember when to use this versus when to use that. But that's why we're trying to have a lot of review time this week, just to work through. You have all the skills to do these. It's just remembering when to use which skill. Are we okay with that so far? So today might be a little bit front heavy, might be a lot to take in. But I believe in you guys because I know, like, we talked about all this stuff. We talked about how to do it. It's just remembering the steps and remembering. So today we're looking for the initial value. So a ball's height when thrown off of the edge of a cliff can be modeled by the function h of t equals negative x squared plus 11x plus 45, where t represents the time in seconds. What is the starting height of the ball before it was thrown? So we know it's an initial value question because they're looking for a starting height, a starting value or an initial value. So we just need to figure out, okay, what is the height? This function, we're told, models the height with t being, it should be x, represents the time in seconds. So it should be h of x equals negative x squared plus 11x plus 15. Now what did we talk about represents our initial value based on from that last page we were just on? Y-intercept. So we're looking for the y-intercept. Y-intercept does not have a q in it, in case you're wondering. There we go. Y-intercept. Earlier we mentioned, and earlier this week, or not this week, earlier 2 weeks ago, we talked about how the y-intercept was always at that c point. X squared plus bx plus c, c was always the y-intercept. So what would be my y-intercept for this function? 145. So at 145 feet, because we said, actually it doesn't tell us it's in feet, but we'll say 145 feet will be the initial value, or that starting height of your ball, because we know that's our y-intercept. Our y-intercept occurs at 0, 145. So 145 is when time equals 0, the ball hasn't thrown yet. What height is it? We okay with this so far? So anytime we're looking for that initial value, initial amount, y-intercept is almost always what we're looking for. That's just one type of situation. This one's probably also the easiest just because typically you can look at it. If it didn't have a c, if it was just negative x squared plus 11x, we just say, well, the height at 0 is just 0 because there's no value. But because they have that c, we just use that as our. Any other questions, concerns, comments so far? Okay. And if I ever say something really confusing, once again, just let me know. Stop me. Talk about it. Rewind. So another thing we're looking for is a maximum or minimum value. So a function h of t equals negative 16t squared plus 128t models the height of a rocket in feet after t seconds. So a rocket goes up, we're looking at that height changing after so many seconds, and then it comes back down. We want to figure out what is the greatest height the rocket reaches. So it's asking for that greatest height, so it's asking us for that maximum value. What's the highest point on this little arc that my rocket launches? So whenever we're looking for a maximum or minimum, we're going to be looking for the vertex. And in order to find the vertex, the x-coordinate of our vertex is always opposite of b over 2a, negative b divided by 2a. The y-coordinate is, we just take that value and we plug it back into the function. So we input that value, and that will give us our y-coordinate. So if we're actually looking for the height, we need to figure out what this is. If we're looking at when it occurs, we'll be looking at for the first term. So in order to find my maximum or minimum, I need to figure out what's my opposite of b over 2a. So what is b for my function? So h of t equals negative 16t squared plus 128t. So if I am ax squared plus bx plus c as my generic, what does that 16 represent? It's going to be my a, because it's with that x squared, or the t squared in this situation. T and x, it's just a variable. So I know I'm going to have negative 16 on the bottom. What is my b going to be?
128.
128. So b is always with the single variable. My single variable is 128. So that was a. This is b. The line. Okay, so 128, but it's always opposite of b. So it's because this is positive, I have negative 128. So the first thing we need to do is we need to figure out what this number is. Negative 128 divided by 2 times negative 16. So 2 times negative 16 is negative 32. So negative 128 divided by negative 32. We can plug that in the calculator and it should give us, I think it's 4. So after 4 seconds is when my rocket hits the highest point. But that doesn't tell us me how high it is. Once I get that 4, I need to plug it back into my function, and that will actually give me my height. So I'm going to take my h of t, but rather than plugging in t, I'm going to plug in 4. So evaluating my function at that value. So negative 16 times 4 squared plus 128 times 4. Every time I see a t, evaluating and plugging it back in. And this will give me the actual height of my rocket. You could also type this whole thing in the calculator at once. Negative 16, parentheses, 4, parentheses, squared, plus 128, parentheses, 4, parentheses. And you can type that whole thing in and hit equals. And that's, you can do it right that. Or you can split up into pieces. It's up to you, whatever you're comfortable with. So this is negative 16, 4 squared is 16, plus 128 times 4. Negative 16 times negative 16 is negative 256. 128 times 4 is 512. Add these two together, and we get 256 is the height of our rocket in feet. 256 feet. So anytime we're trying to solve for a maximum value, anytime we're trying to solve for a minimum value, opposite of b over 2a, figure out what that is, plug it back into your function, and that's going to be your value at that maximum or minimum. We okay with this? Would you prefer to do practice one of these first, or would you prefer to try to move on and try to cover more today and then practice more tomorrow? You want to see something else? Okay, that's fine. I just want to check. So we're going to skip that next one. It's just asking for the maximum height of a softball being thrown. Once again, you do the exact same thing. Opposite of b over 2a, plug it back in. We'll practice with that one tomorrow. Let's look at this one. This one's pretty ugly, but it's nothing we can't handle. So we have the function h of x equals negative 0.0241 x squared plus x plus 5.5. This models the height in feet of a shot put throw after x feet thrown. So it's how far or how high the shot put is after however many feet it's traveled. So after 10 feet, how high it is, after 30 feet, how high it is. We want to figure out how far the shot put goes, or how far the shot put has been thrown. So what we're looking for is when the shot put hits the ground. Where is that point? Well, if we think about it, we're looking for that x-intercept. Trying to figure out when is that x-intercept? When is that shot put touching the ground? What is that value? If we find the value at that x-intercept, then we'll figure out how far that shot put was actually thrown. And so the way we solve for x-intercepts in the past, we've done quadratic formula, or we've done factoring. You can use the calculators. The calculators can find x-intercept for you too. If you plug in calculators and then hit that like second trace intersection, or not second trace 0 will give you those x-intercepts. So we're looking for that point. Based off this quadratic, I don't know about you, I can't factor. I don't know what two numbers get to add up to equal 1 and multiply to get whatever those two multiplied together are. I can't think of that. So I'm going to use quadratic formula because I don't know what to do for factoring. So think about our quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Once again, you'll receive that on your state test. It'll be on a reference sheet. So you'll have that available. So we need to plug in those values. We need to figure out what's my a, what's my b, what's my c. So a is this really ugly decimal. B, my number for my x, which is just 1. And then c, my 5.5. So these are uglier numbers than what we're used to using. But because it's modeling a real life situation. I'm not exactly 5 and 11. I'm 5, 11, something, something with a couple decimals. I can keep going on if I want. You're not going to get perfect numbers in real life, so we're going to get some ugly quadratics. So opposite of b, plus or minus the square root of b squared minus 4ac, which is negative 0.0241 times 5.5. So we have some ugly decimals, so you'll need a calculator on that one. And then over 2 times negative 0.0241. We're just trying to figure out What are these solutions? Once again, I might get two solutions, but we'll have to reason through them. We'll talk about that when we get there. So we always focused under that square root first. Try to figure out what those are. So -1 plus or minus the square root. 1 squared, that's just 1. I can multiply this together. I can get my calculator and do -4 times -0.0241 times 0.5 or 5.5. Multiply all that together. We'll get the beautiful number of -0.5302. I can multiply the bottom part together. That'll give me -0.0482. So we can multiply these together. We have calculators. We can do this. I want to simplify under that square root stuff. So it's -1 plus or minus the square root. 1 minus -0.534 is 0.4698 over -0.0482. This next step, I honestly think was the step I saw the mistakes most. Was people would forget to take the square root. They'd put like 121 in for on their assessment, and then they'd write 121 when they split up the problem. They would just forget to take that square root. So just something to watch out for. That was just a mistake that I saw common on your state test or on your test. And so we take the square root of this, which gives us 0.69. So it's -1 plus or minus, not square root, we already did that, 0.69 divided by -0.0482. Once again, we're just dealing with these ugly numbers. And then from here, I split up in my two problems. I'm going to get my two solutions. I'm going to get a positive answer, I'm going to get a plus and a minus. So it's -1 plus 0.69 over -0.0482, and -1 minus 0.69 over -0.0482. They're each going to give me a solution. -1 plus 0.69 divided by -0.082 is 6.43 feet. And then my other answer is 35.06 feet. So those are the two gross x-intercepts of that quadratic. Now we have to think, when did the shot put hit the ground? Those are 2 points of which the quadratic hits 0, but which of those are actually the points we're looking for? Right, you throw a shot put, right? So if you throw a shot put, do I want to get 6.43 feet or do I want to get 35.06 feet? I want to get 35. I want that thing to go far. So most likely, our answer is going to be the 35.06. Typically, for problems like this, one of your answers should come out negative. One of them should become positive. In this case, we got two positive answers, which is a little different from normal. But if one answer is negative, you don't want to throw that shot put backwards. So that's obviously not true. And with this one, we obviously want to be throwing farther, so the 35 would be the correct answer. Then I think you're doing it wrong. Are we okay with this and how we work through that problem? I know today, once again, we're going through a lot. There's a lot of different things. We're reviewing a lot of different steps from the past that we have to think through. But once again, we'll have a bit of practice. So we talked about four things. We talked about y-intercepts is your initial value. Maximum and minimum, you did the opposite of b over 2a. And then zeros, we use either quadratic formula. Factoring can also work for this. This situation, we couldn't factor it though because of the ugly numbers, but you could also factor some quadratics, and that can also get you x-intercepts. The last one, the last possible situation were the time intervals. So this was always looking for when is my quadratic increasing, when is my quadratic decreasing, what time does that occur? So we have a stock. Everyone in here did Mrs. Ruppright's stock thing last year, right? That was the thing you guys did.
Yeah.
Except for Orlando, I'm sorry. So you know your stocks increase and decrease daily and all that stuff. They're always going up, they're always going down. When to buy, when to sell. A lot of stocks are modeled with quadratics. They'll have a quadratic function. It's not perfect, but it can be modeled that way. So we have the value of the stock is modeled by the quadratic v of x equals 2x squared, actually let's have a seat, minus 3x plus 138. That's the value of the stock, where x is the number of days past that year. So after x number of days, you can plug that in, and that's your value of your stock on that day. We want to figure out when, over what interval is this stock decreasing? When is the stock going down? What time period? Because then if you can figure out when it's going to be its lowest, you can buy it, so you can sell it at its highest, and then you get your most amount of bang for your buck. So, is this quadratic going to be going up or down? Let's first figure that out. To figure out when is it going to be increasing or decreasing? What was that, Brooke? Or Zoe? Up. How do you know it's going up? So our quadratic's going to be going up. The way we always determined whether it was facing up or whether it was facing down was that first number, that A. If my A was positive, we can remember it's happy, it's smiling. If my A was negative, it was upset, it was frowny, it was going down. And so because it's a positive A, we're going to see a smiley face, we're going up. So along what portion of this quadratic am I decreasing? Am I decreasing here? Am I decreasing here? So if I start on my left and work my way right, all I'm decreasing and decreasing and decreasing and decreasing. The only time I stop decreasing is right when I get to that box. But as soon as I get to that lowest point, any point after there, my value is increasing and increasing and increasing. So from when that quadratic starts, all the way to that maximum point, or that minimum point, that is when our quadratic is going down. If I wanted to look for when it was increasing, it would be from after that maximum point or after that minimum point all the way up. That would be when it would be increasing. So we typically for these questions, I like to draw myself a picture just to figure out, okay, where along that quadratic am I actually increasing or decreasing? So I know it's going to be from the first day of that year all the way into that minimum value. That's when I'm decreasing. So I need to figure out when does that minimum value occur? When am I hitting that vertex? So we know the vertex is opposite of b over 2a. That's when we occur. If we plug the value back in, that's the value. We don't necessarily need to know the value at the minimum point, so we don't have to worry about plugging opposite of b over 2a back into our function. We just want to figure out what is that point of when it occurs. And so we just have to figure out when is the opposite of b over 2a. So what's my b for this function? Just 32? Negative 32. I want to keep that negative with it, and because a negative and a negative, that will change. So that gives me a positive 32 in the numerator because it's the opposite. And then what's my a? 2. So it's 32 divided by 2 times 2 is my opposite of b over 2a. 2 times 2 is 4. So 32 divided by 4 equals 8. So after 8 days in that year, that's when my quadratic hits its minimum value. That's when my stock is going to be its lowest point. So I know between 0 to 8, those are the days when my stock will be decreasing. Any point after 8 should be when it should be increasing based off this quadratic. Assuming this keeps this function, it should be increasing. We've done a lot today. Talked about a lot. So we're going to continue to practice this work. We've seen an example, at least, of every situation. Tomorrow's going to be a lot of practicing, going over, reviewing those steps. When do I use this? When do I use that? Wednesday will be the same way, and Thursday will be something along those lines. Any questions? Yes, Landon?
We don't need this. No. Eu matei um bom. Gente, estou uma situação.
Senhora.